Well, hello all. I now have information about Exam 1, and what I'm going to do is I'm going to go through lecture today, then I'm going to actually start going over Exam 1. Three exam questions have already been posted, so you can already start working on it, and you can come to the next class and ask questions about it and everything. Today, this is the last new material that will show up that we'll cover that's on Exam 1, except for there's one reading about the excerpt from Blink. So the information we have on, just a reminder, homework 6 and 7 are due Tuesday at 2:30. And today we're going to do this worksheet. It's about another way of getting information on people's willingness to pay for stakes and figuring out like how much you'll sell. And we're going to discuss Exam 1. Like I have there's a study guide posted on Exam 1. It doesn't really says much, but there's already a draft of Exam 1 where it shows you the first 3 questions. And so you can go ahead and get started on it. As we'll talk about, it's going to be a thing, it has to be offered online. And so it's just going to be like a take-home. I'm going to post it on Canvas on 9/17 at 2:30, so like the beginning of class, and has to be turned in by midnight on September 21st. So you should have plenty of time. Of course, if something comes up and you get sick, we can give you some deadlines. This doesn't mean you should have plenty of time to do this. And it's going to be one thing that's going to be very different about the exam. Everybody, for the first 3 questions, you have to analyze some data, but everybody has a different data set. Like I'm going to show you, there's this web page where you have unique data set for you. All right. Okay. Y'all have no idea how much my nose itches when I put this thing on. I swear it's like all I think about. Okay. So we're going to be going through these slides, but these slides are going to mimic what's on your worksheets. So you should be able to, you shouldn't need to take notes on anything except what's on your worksheets. Okay. We're still talking about value, and you remember from, I think it was maybe homeworks 4 and 5, there was those videos where we were talking about what is value. Usually when we say value, we mean people's maximum willingness to pay for something. And you don't have to know this, but just give you an illustration, like when we value lives, and we do put a statistical value on lives, I think it's about $6 million per life. They calculate that based on the amount of money that people are willing to spend to reduce their probability of getting killed. Like if you take a pay cut to work a safer job or something like that. So anytime economists look at value, we're talking about people's maximum willingness to pay. You've seen in the video there was that weird second price auction we did where we got people's value for RBST free milk. And in the last class, we did those scales where we said, okay, here's regular beef on a scale of 0 to 100. How likely are you to buy it at this price? And then we had guaranteed tender beef on a scale of 0 to 100 at this price. How likely are you to buy it? And then we used those answers and did some algebra to figure out the maximum amount someone would pay for a guaranteed tender steak, or the maximum premium over a regular steak. We're going to keep with that example, but what we're going to do here is we're going to look at a much simpler way of doing this. So rather than using scales and having to do algebra, and rather than using an auction, there's nothing wrong in some cases just answering a very simple question like this. And so this might be a case where you bring people in a room and you actually let them get to choose between different steaks, or it might be an internet survey. But the point is we have this new steak, a guaranteed tender steak, and we want to know how much will people pay for it relative to a regular steak. And so we pose the question like this. We say, okay, suppose there's a regular ribeye that sells for $8 a pound, and then you can also get these guaranteed tender steaks. If the regular ribeye is $8 a pound, what's your maximum willingness to pay for the guaranteed tender steak? And we start them off $8 per pound or less. That's just that, even though you would think almost anybody would be able to pay, willing to pay a little more for a steak that's guaranteed tender, you want to have that there for completeness. Maybe some people have some kind of weird notion about why it would be tender in the first place. Maybe they think it's from a different type of cattle that will actually taste less or something like that. And then, so we give them a choice, $8 or less, and then we say 8 or 9. Remember what we're saying here. We're giving them, we're saying you're in the store, typical ribeye is $8 per pound. Alongside that ribeye is an identical looking ribeye. It's important to say that. An identical looking ribeye with the label guaranteed tender, meaning it's verified to be tender. What's the maximum price you would pay? So someone's maximum would be $8.50, so they're only willing to pay 50 cents more per pound relative to the regular one. They would choose $8 to $9 per pound. So anybody that chooses $8 to $9 per pound, we don't know exactly what their maximum willingness to pay is, but we know it's somewhere between 8 and 9. And then we also have, we go 9 to 10, 10 to 11. Sometimes to be more exact, some people may say greater than 10, less than or equal to 11. That's a way of being more exact. Because suppose their willingness to pay is exactly 9. Do they choose this one or that one? But you may judge that either one they choose is fine if their willingness to pay is 9, and you don't want to make the question more wordy than you need to. And so we give them all these different choices. And so if someone is willing to pay $12.02 for the guaranteed tender steak, they come here and they choose the 12 to 13. And then we go up to 14 to 15. We have to stop somewhere, and you have to make a judgment about what would be like a ridiculously high price. And I said, let me just make this choice if they're willing to pay more than $15 per pound. And so what they're willing to pay is $15.02. They choose 15 or more. If their willingness to pay is $25, they choose 15 or more. And then you always want something there to tell you if the person would not buy it in the first place. I've got this, I would never purchase a ribeye steak. In hindsight, that's probably not a great way to do it. Probably a better way of asking it is to say, okay, suppose you're going into the grocery store, this is the setting, what would be your most likely behavior? And then you could have here just not purchase a steak rather than I would never purchase a ribeye steak. But we'll keep going with it. So now what we want to do, histograms, yeah, you did histograms in your Intro to Stat course, but you've probably kind of forgotten what it is. But histograms can be one of the most important ways to analyze data because they're very informative and they're simple to interpret. And I'm going to be a bit elementary. We're going to kind of do it from scratch just to make sure you remember everything about what a histogram is. On one of your test questions, you have to construct a histogram in Excel. So we're going to have a hypothetical example here. And we're going to say that suppose we get answers from 20 people, and these are the answers that they give. So what we have is, so this would be like the 20 responses. This is subject number 1 said 8, which means $8 or less. Subject number 7 said 12, which we interpret that to mean 11 to 12. So the point is when you go through and count how many people did each response, we get here. So one person said $8 or less, 3 people said $8 to $9, one person said $9 to $10, nobody said $10 to $11, and so on. And then there were 20 people here, and so we also do this percent. So what I did here, and so I think you should put this table down there because we're going to be filling in a histogram soon. So I would put these different categories right there and put the number of people there. 8 people said they would never purchase a ribeye. There will be a test question where I give you a scenario like this and ask you to do something with it. And we don't just want the number of people who provided each response. What we really want is the percent of people. And so the percent of people who said they would pay $8 or less, there was only one person. In reality, we'd always have more than 20 people, but I'm just keeping this simple. There were 20 people, so 1 divided by 20 is 5%. 3 people said $8 to $9. 3 divided by 20, 15%. 8 people would never purchase a ribeye. 8 divided by 20, 40%. And we'll know we have these percents right when we sum them up and they sum to 100. Okay. And always tell me if I go too fast. I know sometimes when you're writing, you're still doing. I know sometimes when you're writing, you're just doodling, so it's hard for me to tell. All a histogram is a bar graph of those percentages right there. That's all it is. And so when we make this histogram, and I'd like y'all to just draw it in, that way you really remember what a histogram is. So what percent of people said 8 or less? 5. And so we just draw a bar that goes from here to 5. How many people said 8 to 9? 15. So there we do a bar that just says 15 like that. And when you fill them all in, this should look like that. And our big question here is we're going to sell this thing. So if we're going to sell guaranteed tender steaks, we're trying to figure out what price we should sell it at. And whatever price we sell it at, we need to figure about how many are people going to buy, because we don't want to buy too little or too much. And so this histogram lets us simulate what real shoppers do. So we give people this survey. It gives us an idea of what they do. We use it to simulate what would happen in a real store to figure out, is this price good? Is that price good? If we buy this many steaks, is that enough? That kind of thing. And so, for example, number 2 on the worksheet, this may be a really important question we have. We say, okay, based on these data, let's simulate grocery store activities. And we say, okay, suppose the regular ribeye sells for $8 a pound. What if we sell the guaranteed ribeye for $11.99? And suppose 100 people pass by the steaks. What we want to do is take from this histogram and say, well, how many would not purchase a steak? How many would purchase the regular ribeye? How many would purchase the guaranteed ribeye? We're going to be doing the numbers and percentages, but you can imagine if we want, if we know in our store that 100 people are going to pass by the meat counter per hour, then that can help tell us exactly how many, roughly how many guaranteed tender steaks people will buy in an hour. And here's how we use this. We say, okay, we're selling this for $11.99. This histogram tells us people's maximum willingness to pay for it. So our price point is just what, instead of price, industry likes to use the word price point. I don't know why. We're setting the price at $11.99. So let's just say it's like 12 here. Okay, so remember there were 3 people here, or 15% of these shoppers. At a price of $11.99, will these 15% of people buy the guaranteed steak or the regular ribeye steak if they buy one? What's that? Yeah, the regular. Because here's what's going on. They're saying by choosing $8 to $9, they're saying the maximum I would pay for this guaranteed tender steak is somewhere between $8 and $9. But we're selling it for $11.99. So we know that they would not buy this. Now, we're also going to assume that all those who didn't select I would never purchase a ribeye will purchase one of the ribeyes. And so where we know that 40% aren't going to buy anything, but we want to know what percent are going to buy the guaranteed tender. Okay, so we said, well, these people aren't going to buy it. At $11.99, these people won't, because most of them are going to have a willingness to pay somewhere less than $11.99. Maybe one person who was right at $11.99, but so what? What about these people? They going to buy it? Yep. They told us their willingness to pay was between $12 and $13. We're selling it for $11.99. They're going to buy it. So 5%. These 5% will buy it. Will they buy it? Will they buy it? Yeah, will they buy it? Yep. So the percent of people who go by this counter and buy the guaranteed tender steak is 5% plus 5% plus 5% plus 10%. Does that make sense? Okay. See, that's taken a really simple survey question and been able to actually simulate grocery store behavior. And yeah, so we know that these people are going to buy the guaranteed tender steak because their willingness to pay is greater than that price. And so 25% of shoppers. So we know 40% will not buy a steak, 25% will buy a guaranteed tender steak. Well, these percentages have to sum to 100. The only other alternative is to buy the regular ribeye, and so it must be that 100 minus 40 minus 25, that 35% buy a regular steak. Which another way of looking at that is all of these people would buy the regular steak, 5 plus 15, 20, plus 5, 25, plus 10, 35%. So again, what we're doing here is we're selling this new steak. How many are we going to sell? Nobody has any idea. We've never done this before. But we need to have some kind of indication of how many people are going to buy these guaranteed tender steaks. So we do a survey. The survey's not perfect, but it gives us a rough indication. As long as you know how many people are coming into a store, gives you a rough indication of how many guaranteed tender steaks you may need to sell. And it tells you something about market share too. And we're going to spend a lot of the rest of this talking about market share, so let's just look at one quick way of calculating market share. Suppose we want to know the market share of guaranteed ribeyes among both regular and guaranteed ribeyes. So we're saying out of all the steaks, all the ribeye steaks that we sell, what percent are guaranteed tender and what percent are regular? Well, if we say, we're saying we'll sell 25 units of the guaranteed tender steaks. We're assuming each person, we said 25% would choose the guaranteed tender. We'll assume that they just purchase one every time. And so for every 100 people, you're selling 25 guaranteed tender. The total number of steaks you're selling is 25 plus 35. 25% of people do guaranteed tender, 35% do the regular ribeye. And so 41.6% of all the steaks sold will be guaranteed tender. Do the same calculation for the regular, and you get 58.3. Of course, those two should sum to 100. So from that, we've also got a pretty good indication that at that price, the market share of guaranteed tender will be about half. It'll be about, sell 50% of all your steaks will be guaranteed tender. Well, suppose we know our supplier can only provide us 20% of guaranteed tender. So at any one time, out of all the stakes we have, only 20% guaranteed tender. What might we want to do about the price that we sell the guaranteed tender? That's right. Might want to jack it up. And you can imagine using this histogram to figure out, okay, how high does the price have to go until only about 25% of people would buy the guaranteed tender? That would be this 10 plus that 5, another here, so, maybe around $13 or something. Anybody good? I can't see students cry like I normally can with the mask. It even hides stuff. Okay, that's pretty simple. That's something I definitely want you to know. The rest of these questions are really just about adjusting some of these percentages to evaluate some different scenarios. And the next question is just kind of it's more of an abstract problem just to make sure you understand what we're doing here. And so we have this situation, and our market shares, those were like probabilities. 25% probability they'd buy this, 35% they'd buy that, 40% they'd buy nothing. And suppose we have 4 different probabilities here, X1, X2, X3, X4. Maybe those are 4 different products. And we know that that's all one product, so the probability, if someone buys one, they have to buy one of those 4, and so those probabilities sum to 1. But now, and you'll see a realistic case of this in a minute, so now suppose we have a scenario where X4 is no longer a possibility. And so when people go to buy this thing, they can't buy X4 anymore. Then we want to say, well, what will the market shares of like X1, X2, and X3 be? And we have to make some assumptions. We say, maybe this is what we say. We say, okay, if they don't buy X4, they're going to buy X1 or X2 or X3. Moreover, they're going to buy the ratio in which they buy X1 and X2 would be the same regardless of whether X4 is there or not. And so how do we adjust the probabilities of X1, X2, and X3 to represent the new absence of X4? And one way of doing this is to say, I want to multiply each of those probabilities by some constant factor there. And I want that factor to be such that the new probabilities sum to 1. So whereas the old probability was X1, the new probability is gamma times X1. Whereas the old probability was X2 for good 2, the new probability is gamma times X2. And notice if we do this and we choose the right gamma, the ratio at which X1 and X2 is sold will be the same. Because X1 divided by X2 is the same as gamma times X1 divided by gamma times X2. And then notice this, and this is just a little trick you have to do. This is the important step you've got to be able to do on these other problems. Note that we had this equation right here, right? Well, suppose we get rid of X4 by moving it to this other side. So now we know that X1 plus X2 plus X3 equals 1 minus X4. But what we want is X1 plus X2 plus X3 to times something to equal 1. Well, we can just take 1 minus X4 and bring it down to the denominator. We get that. And so that tells us that the best gamma, the gamma we want, is just 1 divided by 1 minus X4. And so if we choose gamma equals 1, and this is the answer there, this is the answer you want to put, 1 divided by 1 minus X4, then when you multiply that times these, it will equal 1. So again, the gamma is 1 divided by 1 minus X4. Now, let's see an actual application of this. Suppose we have this scenario where we have 5 different steaks on sale here. And over a course of a number of months, we observe this market share. So we tend to see sirloin steaks selling about 30%. So out of all the steaks sold, 30% of them tend to be sirloin steaks. New York strips tend to be about 10%. So those are the old market shares. But now we have a scenario where for some reason, New York strips were no longer available. So just like X4 was no longer available, now New York strips are no longer available. And so now we want new market shares for the sirloin, ribeye, T-bone, and filet mignon. And well, we just do that little trick. We want to multiply each of these probabilities by a gamma. In the other problem, we saw that gamma was 1 divided by 1 minus x4. What was x4? Is that probability of the fourth one being chosen. So we want to multiply each of these by 1 divided by 1 minus, any guesses? What's that? Yep, 0.1. And so we just do this. We take 30%, 0.3 divided by 1 minus 0.1, so we'll divide it by 0.9. We get a new market share of a third. For these two, the new market shares are 22.22%, and these new probabilities should sum to 100. And so you're just reallocating old sales to other products in the proportion that they've been consumed in the past. While you're writing this down, I'll tell you, you don't need to know this, but interesting thing about filet mignons. So that's the tenderloin of the cattle, and tenderest part. It's usually the really thick steak. Often they sell it with a piece of bacon around it. It also has the least fat. That's why they put the bacon on it sometimes. The vast majority of the demand for filet mignons comes from restaurant and by female consumers. Overwhelmingly, females are the big consumers of filet mignon. I don't know exactly why that is. And so the biggest day for filet mignons is Valentine's Day, because that's when women are taken out to eat more than usual. They're the big consumers of filet mignon, so they keep a lot. That Valentine's Day is the big day for that. We good? We'll do that in a minute, but let's, number 5 says, let's return to question 2. What's the market share of regular ribeyes and guaranteed tender ribeyes? We can do that this other way as well. And so, let me, okay, so going back to number 2, where there was only 3 options people could choose at the prices of the regular and guaranteed ribeye. So we had the regular ribeye at $8. We had the guaranteed ribeye at $11.99, and then we had none. And then we said, what percent would choose none? What's your histogram say? 40%? What percent would choose the guaranteed tender? At the price of $11.99? What's that? Yep, 25%. And 35%. And this was a case where these were the only three options they had: buy this steak or that steak or none of them. And we looked at how you calculate the market share of regular ribeyes and guaranteed tender ribeyes one way. Now let's do it this other way. Now we're saying, suppose we get rid of this none option, and then we want to reallocate those percentages. So now we're saying, let's just look at people who are buying steaks and the choices they make. Well, the percentage here for a regular ribeye was 0.35. And so we want to multiply that by something. We'll multiply that by 1 minus what? 0.4. Same thing for the guaranteed tender ribeye. We take 25%. By 0.6. And if we did everything right, $0.58, and the other one, $0.42. And so the market share for regular ribeyes would be 58%. Guaranteed tender ribeyes would be 42%. That's what we found there. Part of this industry uses market shares and stuff all the time, so I just want to make sure you have a really good understanding of it, however simple it may seem. And so now, last thing we want to do here is y'all have already made this histogram. Well, now we've got a new histogram on this last page, except the main difference is, whereas before you had a thing all the way at the end that said none, I would never buy ribeyes. Now we're only including people who would buy a steak. So whereas there were 40% of people who before said, I won't buy any steak, we're getting rid of those people. And so we want to adjust all these percentages to account for the fact that the only people there now are the people who either buy the ribeye or the guaranteed tender. And so we got to adjust all those probabilities, and so we can multiply each of them by what? You know. You can do it. 1 divided by 1 minus point. So we're getting rid of those people. So we go 0.05 divided by 1 minus 0.4. It's like if you came here, if you did, we had 0.05 up here. Now we're multiplying each of these percentages by 1 divided by 1 minus 0.4. 8%, 25%, and so on. And if we did those right, all of those percentages should sum to what? 100. And so now you've got a new histogram, and just fill in those percentages there. Make your new histogram chart. Meaning in the $8 to $9, you should have 25%, whereas before it was just 15%. So again, what we're doing there, you have this little survey you did where you ask people how much their maximum willingness to pay for something, and you get all these percentages. And you can use those percentages to do thought experiments on a lot of different things. Like, what if we sold the guaranteed tender stakes at this? You could, imagine this was more complicated where we had a lot of different stakes there. You can imagine, maybe, hopefully now you can see if we say, okay, what if we just sold these 3 different stakes? Or what if we sold all 5 different stakes? So you can start with some really simple, just percentages. You can imagine going into a spreadsheet and doing lots of what ifs. What if the prices are this? What if we sold these but not this? And get a lot of output. And a lot of times, what businesses really find is that the actual numbers you get may not be all that important, but what it did is it made you really think through the problem of what you're doing here. Made you really look at all the different alternatives you had of different ways of selling things. And so it's just a way of really making sure you've thought through the problem. And of course, remember that sometimes, if you're actually trying to sell these guaranteed tender stakes and you're going to a grocery store and you're trying to convince the person that they will sell, having actual data showing that the predicted market share is like 40% is really helpful. They're probably going to assume it's a little high. That if you say 40%, they'll probably assume it's more like 25%, but still you've got some data there. And if your data actually does match up with sales pretty nicely, then you have established a very good reputation with that person. Next time you come in with a new product and you say it'll sell, they'll believe you. One cool thing about food marketing is that it can make use of lots of different talents. If you're a really quantitative person, there's lots of cool quantitative stuff you can do it. If you're very artsy and you hate numbers, there's a place for you there as well. You want to see parts of the test? Okay. Okay, let me show you what we have up so far. So when I give out the test, you'll be able to go to Exam 1 under Assignments, and you'll be able to actually download the test. And it'll look something like this. Over here in Modules, under Exam 1 Information, I've got this. So this is draft of first 3 questions. And notice that it's going to say each student has their own unique data set. So no point in copying someone else's. And it's got one link there to it. It's got Another link is under modules. So data for exam 1. So you can go there. And then all you need to do is find your student ID number. So if this is you, 2006-5304, you want to download data for question 1, data for question 2, and data for question 3. And I would definitely go ahead later this week and make sure your data's there. Make sure when you download the data, it actually brings up data. Because I wrote a program to do all this, so it's not like I went in there and made sure everybody's data looks right. Let me pull up this first one. This is basically recreating what you did for, what was it, homework? You know, one of the homeworks where you had to do a pivot table and make a bar graph? I don't think it's due yet, so you might not have done it yet. But notice here we have 4 different flour types. There's white flour, organic whole wheat flour, semolina flour, regular whole wheat flour, and we have 2 different stores where they're sold at, and we have the price. And what it wants you to do is to use pivot tables. So it's going to say, it's showing you, and there's 5,000 observations, so you can't do it by hand. Use pivot tables, and it's asking you, what's the average price of organic whole wheat flour at Walmart? Average price of organic whole wheat flour at Sprouts. It's the average price of semolina flour across all stores. And then I say I want you to make a bar chart like this. And notice I say I want you to make it almost identical to this. Your numbers will look different, but I want it to have the same, and I specify up here, Garamond font, black, bold font. Use the same chart titles, the same y-axis titles, use virtually the same colors. You definitely have to have these data labels up here, otherwise I can't really grade it. That's how I'm grading it. That and its appearance. Okay. Now, of course, if you haven't done this before, that may look a little scary. You may say, I haven't really done pivot tables, I haven't done the bar chart. Well, no, when you do it, so... Okay, yeah, yes. Yeah, homework 6 is the one where you do something like this. It's got a whole tutorial right there that shows you how to do it. It's a different example. There they're doing steaks, and in the exam 1 they're doing flour. But if you can do that homework, you won't have any trouble with the exam question. And it also shows you how to make the bar chart as well. So you can even do those at the same time. Like since the question's up already, you can go ahead and do homework 6 and do that first question from exam 1 kind of at the same time. Second question on exam 1. This is a little different. So this is having you make a histogram using some data. So like if you're this student and you download data 2, this is what the data looks like. And we want you to make a histogram from here. And I'm even telling you what bins and use to everything. Now you may look at that and say, well, I haven't really done a histogram either. And so you need to know that, and we did one histogram today, but you don't know how to do it in Excel yet. There's an actual, I need to put it up there, but there's a whole YouTube tutorial on how to do that as well. And it's virtually identical data, so you just have to follow it step by step. Your numbers will look different. The actual numbers you get will look different, but you can just follow the exact same steps. So that shouldn't be hard. And then again, it's going to tell you, I want a graph that looks exactly like this, except some of your numbers will look different, but the tutorial shows you how to make that. And it even shows you how to put this little thing in there. So you just got to follow it step by step. This is me trying to make absolutely sure you know how to do some data analysis in Excel and that you can make nice, attractive charts. And again, one of the important things is that you have these data labels up there, because I'll have one computer where I can just put in your number and it shows me what those numbers should be. Then I can look at yours and tell whether you've got the right numbers or not. And then question 3 should look familiar. Okay. So remember in last class we took a problem like this and we used algebra to figure out people's maximum willingness to pay for guaranteed tender steaks. We calculated their utility function for regular ribeyes, utility function for guaranteed tender ribeyes, I should say. And then we say, if regular ribeyes sell for this, the most they would say pay for guaranteed tender steaks is. And again, there, you have to, if you're this student, you download the data for number 3. And so this is telling you what the scores are. For instance, notice it's showing you here. In class, we had a score of 54, but it says, do not use these scores. The unique scores for you are located at blah, blah, blah. And so this means the score for regular ribeye for you at $8 per pound is 42. So instead of the 54, you should be using 42 there. So that is just repeating what we did in the last class. And so those are 3 questions. That's a good bit of work. But, you know, those first 2, you've got tutorials that show you exactly how to do everything. And the last one we did in class, so it's just a matter of spending the time to do it. And then the rest of the Exam 1 study guide. So it's telling you when it's going to be posted and everything. It gives you the link one more time of where that data are. And then I've already told you what the first 3 questions are. And then the rest says the rest are going to be short answer and essay questions. And of course, you know, since this is take home, it's not going to be just simple like multiple choice, like what's this definition. There are going to be questions where you have to think and you have to pull in vocabulary and concepts from a lot of different of our studying to answer that question. And it tells you what we cover here from the textbook excerpt. It just covers 1 through 6 and pages 13 through 23. There's a lot of pages in there about price with a bunch of formulas and stuff that we never covered or anything. That's not in there. So just those page numbers. All the material and lectures, the panoramic fog article, all materials and homeworks we did. And this is a new assignment excerpt from Blink. It's just Blink's a book by Malcolm Gladwell. It's a really easy, fascinating read. It's just 1 chapter of that. Okay. So that's the exam. There's a lot there, right? We've got today, Monday, and then it goes up on Wednesday, right? That's the 17th, or what did I say, the 14th? Yeah, so we've got Monday and Wednesday. And so what you can do, I plan to cover some of the stuff from Blink a little, some of the main things we'll talk about on Monday, but also I won't plan to do anything Wednesday. And so that's when you need to go ahead and ask for help. So I'd say don't wait till it goes up. Go ahead and get started on those 3 problems now. That way it's really easy to ask me for help when you have trouble with it. It's nothing of it's really hard, but you know, sometimes when you do something new in Excel, there can be something, just a small little thing, and you know it's simple, but you're just not seeing it. And that's what you need to ask me for. Does that make sense? Okay, so I think if I was you, the first thing I would do is start finishing homework 6 and do question 1 there at the same time. I think that'd be the best use of your time. And have a good weekend.